Good morning, everyone. This is Antonia Jaramillo with NASA Communications. Thanks you all for joining in. I believe we are ready to get started, so I'm going to pass it over to our moderator, Nilofer Ramji, whenever she's ready.
Hey everyone, hello and welcome to NASA's Lunar Science Media Briefing for the agency's Commercial Lunar Payload Services, or CLPS initiative. Today's briefing will preview the NASA payloads flying aboard one of the first CLPS flights, Astrobotic's Peregrine Mission 1. Astrobotic is scheduled to launch aboard ULA's Vulcan rocket no earlier than January 8, 2024. This briefing will address the significance of the NASA CLPS flight and highlight the NASA-provided payloads aboard Astrobotic's Peregrine lunar lander. Our briefers today are Chris Culbert, Program Manager for NASA's Commercial Lunar Payload Services, Nikki Werkheiser, Director for Technology Maturation for NASA's Space Technology Mission Directorate, Paul Niles, CLPS Project Scientist from NASA's Johnson Space Center, Nic Stoffle, Science and Operations Lead for the Linear Energy Transfer Spectrometer at NASA Johnson, Tony Colaprete, Principal Investigator for the Near Infrared Volatile Spectrometer System from NASA's Ames Research Center, Richard Elphic, Principal Investigator for the Neutron Spectrometer System at NASA Ames, Barbara Cohen, Principal Investigator for the Peregrine Ion Trap Mass Spectrometer at NASA's Goddard Space Flight Center, and finally, Daniel Cremons, Deputy Principal Investigator for the Laser Retroreflector Array at NASA Goddard. First, we'll start with some initial remarks from each of our briefers before opening it up for questions. We'll be taking questions online, so if you've joined us today, please raise your hand and add your name to our queue and ask a question. You will be unmuted to ask your question. Once your name is called, please state your name, affiliation, and to whom you'd like to direct your question. We'll now begin with comments from Chris Culbert. Chris?
Good morning, everybody, and thank you for joining us. We are really excited to start this new American adventure on the moon. Under the Artemis umbrella, robotic spacecraft will conduct important scientific studies preceding and in parallel with exploration by astronauts at the lunar South Pole. NASA has a long history of successful robotic scientific missions throughout the solar system. We all know about the Perseverance rover on Mars. We've heard about the OSIRIS-REx returning asteroid samples. And of course, we've all seen the amazing photos from James Webb Telescope or the Hubble Telescope. This work over many decades and the cumulative careers of hundreds of employees has helped develop best practices for mission success. Even so, we continue to ask ourselves, what else can we do to make this successful? 5 years ago, we started a new, very different, innovative approach for doing science on the moon. As NASA explores the lunar surface under Artemis, we will leverage the capabilities of American companies. Rather than NASA owning the mission and operating traditionally, NASA is making a concerted effort to use commercial services and public-private partnerships. So instead of designing and flying NASA lunar landers, we are contracting with American companies to take our scientific experiments, engineering tests, and technology demonstrations from the Earth into space and land them on the moon and send the data back to Earth. This deliberate change leverages the innovation and entrepreneurship of American private industry to accomplish public goals. If there are American companies providing a delivery service to the moon, the cost of buying a service is much less than NASA owning the end-to-end mission. Our goal is to increase the number of missions we can conduct each year and eventually develop commercial service providers for Artemis. At this point, NASA will be just one buyer of many for lunar lander services. NASA's Commercial Lunar Payload Services, we call it CLPS, uses fixed price service contracts, not traditional spacecraft development contracts. The important thing to note here is that these lunar missions are the company's commercial missions. These are not NASA missions. We have asked industry to build a lunar lander, arrange for launch services, and plan the end-to-end mission to the moon, ending hopefully in a soft landing on the moon. Then we will ask the companies to enable our instruments to operate on the lunar surface and return data to Earth. This whole task is not easy. Landing on the moon is extremely difficult. We recognize that success cannot be assured. The surface of the moon holds many robotic spacecraft that were not able to land softly and complete their missions. With CLPS, American companies are using their own engineering and manufacturing processes instead of NASA procedures and oversight to fly their missions to the lunar surface. In the last decade or so, industry has competed to land on the moon via the Google X Prize, or they've worked on lunar landers as part of NASA's Lunar Catalyst program. American industry believes they are ready to provide this service, and CLPS is our opportunity to test that. Dr. Thomas Zurbuchen, who was the former head of the NASA Science Mission Directorate, described CLPS using a sports analogy. Each landing attempt is like taking shots on goal. The more shots, the more opportunities you get to score. Today, we don't know how many of these early attempts will be successful, but I can tell you that these American companies are technically rigorous, they're very business savvy, they're resourceful and driven. They want to secure the first mover advantage in enabling a lunar economy. NASA can use their drive to advance science and technology on the moon and help us prepare for the broader Artemis program. We are on the brink of our first 2 CLPS landings, and others will follow. To date, the NASA CLPS effort has generated progress on 5 different types of U.S. lunar landers, a chain of high-tech part suppliers to allow production of lunar landers, which did not exist before, and new technical approaches and innovative ideas. NASA's strengthened contracting with multiple CLPS providers for a wide variety of NASA payloads has allowed the companies to demonstrate different strengths, different approaches, their own approach to designing and the technology needed to land on the moon. Today, you'll hear about the first set of NASA payloads headed to the moon for what we expect to be the first launch of Peregrine Mission 1 from Astrobotic technology. This upcoming year will be very, very exciting. Thank you for joining us.
Definitely very exciting. Thank you so much, Chris. Next up, we have Nikki Werkheiser. Nikki?
Good morning, everyone. As Nilüfer mentioned, I'm the Director for Technology Maturation in NASA's Space Technology Directorate, where our mantra is Technology Drives Exploration, and our charter is to develop transformative technologies that support science endeavors and human exploration and enabling new missions and discoveries. Like all NASA technology development investments, this mission is not only made possible by solid engineering and science, but also through novel partnerships that spur innovation in the national market by propelling technology into the future. This mission is a shining example of that when you consider that NASA's space technology investments in Astrobotic for over the last decade have resulted in approximately 40 small business innovation awards, you'll hear about some of those today, and 3 tipping point awards to help mature the required lunar technologies. Now I'm going to share some of the Space Tech sponsored technologies being demonstrated on this mission. Astrobotic's Peregrine lander uses novel industry-developed technology for its axial engines, never before flown in space. These thrusters were developed via a 2018 Tipping Point Award, which created the opportunity for industry to partner in maturing this technology. NASA also provided subject matter expertise and facility support to help in the development and the testing of the flight thrusters. Also, the onboard navigation Doppler LiDAR, or NDL, will provide precise altitude, speed, and direction to the guidance, navigation, and control. And that will enable the Peregrine lander to land safely on the lunar surface. Like the thrusters, this novel technology will be flying to the moon for the first time after a series of successful suborbital tests. The NDL will provide enhanced GNC capabilities and accuracy with reduced size, weight, and power, and it's a technology that NASA wants to prove for use on future CLPS and Artemis missions as well. Lastly, terrain relative navigation, or TRN, is used to increase landing accuracy and help spacecraft avoid surface hazards. Much of the science that we want to conduct on the moon takes place in hazardous or challenging environments, and TRN will allow us to access those safely. TRN uses a camera to correlate visible terrain features to onboard maps, calculating relative positions and altitudes during descent within seconds. It can also autonomously navigate spacecraft away from medium to large hazards within a target landing zone in order to ensure a safe landing and a successful mission. NASA and Astrobotic are partners in technology development, and this first CLPS flight represents a full circle moment for these meaningful investments. We are thrilled to be part of this history-making mission. Thank you.
Thank you so much, Nikki. Over to you, Paul.
Thank you. For me, CLPS represents an exciting new way to do space science and exploration. Astrobotic is delivering 5 NASA-sponsored payloads to the moon, and several of these are scheduled to fly again on subsequent deliveries to different landing sites. This higher frequency means that our science teams will gain experience with each delivery, as we learn more about the moon and how each of these instruments operate in the lunar environment. We'll also be able to acquire the same kind of data from multiple places on the moon. This is something we routinely do on the Earth, and that will significantly improve the overall science return. Astrobotic's Peregrine Mission 1 will be landing in a region called Sinus Viscositatis, or Bay of Stickiness. This name alludes to the nearby Gruithuisen domes. The formation of the domes is a scientific mystery we are still working to understand. One idea is that the domes formed from a different kind of lava than the lava that formed the dark lunar mare, which are the dark regions we can see when we look up at the moon at night. The lava that formed the mare created large, relatively thin flows across the surface of the moon. However, the domes could have formed from stickier lava with a different composition that formed clumpy hills. A future CLPS delivery will bring the Lunar Vice instrument suite to the summit of one of the Gruithuisen domes in 2026. Sinus Viscositatis, where Peregrine 1 is landing, is a smooth mare unit near the domes. Measurements of this mare will help understand the overall geologic history of the region, and both radiation and multispectral measurements could complement the Lunar Vice measurements of the domes when it lands in 2026. The mare provides this relatively safe landing zone for Peregrine lander and an exciting place to do our science. The particular suite of payloads on Peregrine 1 has some interesting synergies that will make it important contributions to lunar science and exploration. 3 of our instruments will collect data on lunar volatiles using different techniques. 2 instruments will provide perspectives on the radiation environment at the lunar surface, helping us better prepare to send crewed missions back to the moon. We'll also learn information about the composition of the surface by evaluating its mineralogy. While we have the payload teams on, I'll let them talk more about the specifics of their measurements. But first, I want to introduce the instruments. But before that, I want to say that it's been my pleasure working with these scientists and engineers who are some of the best that NASA has to offer. The instruments flying on Peregrine 1 lander are the Linear Energy Transfer Spectrometer, or LETS, which is a radiation monitor that will measure the radiation environment during lunar cruise, lunar orbit, and on the surface. It was developed at the Johnson Space Center. The Near-Infrared Volatile Spectrometer System, or NIRVIS, is a suite of sensors that includes a near-infrared spectrometer, a thermal radiometer, and a high-resolution 7-color imager. It enables the measurement of surface hydration in volatiles by measuring the presence of water or hydroxyl. It can also identify surface minerals using spectroscopy. It was developed at the Ames Research Center. The Neutron Spectrometer System, or NSS, will measure the flux and energy of neutrons present in the lunar surface environment, which can be used to infer the amount of hydrogen present in the environment. It was developed at the Ames Research Center. The Peregrine Ion Trap Mass Spectrometer, or PITMAS, will investigate the lunar exosphere using a compact mass spectrometer. PITMAS was developed via a partnership between NASA, the Goddard Space Flight Center, the Open University, and the European Space Agency, or ESA. The Laser Retroreflector Array, or LRA, is an array of 8 retroreflectors on a small aluminum support structure. It will enable future precision laser ranging from orbiting or landing spacecraft to determine the distance to the LRA on the lander. It was developed at the Goddard Space Flight Center. Thank you.
Perfect. Thank you so much, Paul. We will now hand it over to our CLPS payload teams. Let's begin with Nic Stoffle for the LETS payload. Nic?
Morning, thank you. I'm Nic Stoffle. I'm the Science and Operations Lead for the Linear Energy Transfer Spectrometer, or LETS payload. LETS is a small, low-power radiation detector that's derived from heritage hardware flown on the International Space Station in Orion. The instrument uses the TimePix pixel detector technology to measure the patterns of energy deposited by ionizing radiation passing through the silicon sensor. LETS provides us dose and linear energy transfer data, and dose is the sum of the energy deposited in the silicon sensor, with linear energy transfer being the energy lost along the track of individual ions as they pass through the sensor. Both are calculated from the energy patterns recorded in the TimePix pixel matrix. The combination of dose and LET also lets us translate data into more biologically equivalent values that we can utilize for crew radiation protection during future lunar operations. We'll collect data during the lunar transit, lunar orbit, and surface operation mission phases. And with luck, we'll be able to measure a solar particle event during the mission as well, which will give us insight into how such an event will affect the local radiation environment on the surface before crew arrive. I look forward to the upcoming launch and analyzing the data we'll receive from LETS, and thank you for your time.
Thank you so much, Nick. We'll now hand it over to Tony Colaprete. Tony?
Thank you. My name is Tony Colaprete. I'm at the NASA Ames Research Center. I'm the PI of the NIRVIS instrument. As the name implies, NIRVIS is a system of sensors, actually. It includes a spectrometer, a near-infrared spectrometer that measures the volatile content and composition of the lunar soils. It has a high-resolution multicolor imager that provides context for that spectrometer measurement. It also gives us a sense of the very fine-scale morphology of the surface we're looking at. And then it has a 4-channel temperature sensor. It's a thermal radiometer. It simply just measures the surface temperature. As it says in the name, near-infrared volatiles spectrometer system, we're mostly interested in volatiles. And volatiles can be loosely defined as any compound that moves from a solid to a vapor at relatively low temperatures. That's why we're simultaneously measuring temperatures with the composition of the surface. So over the course of the lunar day, we can monitor how any kind of volatiles, for example, water, might be changing as the course of the lunar day as the surface temperature warms, surface temperature cools. Combining these measurements will help us understand more broadly how water might migrate across the lunar surface, making its way from low latitudes, where the Peregrine mission is going, to higher latitudes near the poles, where there are permanently shrouded craters and potential cold traps for these volatiles. One aspect of the NIRVIS instrument that is in the spirit of CLPS is that a good portion of it was developed through the Small Business Innovation Research Program. This is a program within NASA that helps actually bring technologies from small businesses into the NASA mission. It helps both the business and NASA. The spectrometer on NIRVIS was developed, the technologies that were developed through that program. A copy of NIRVIS is flying on the Volatiles Investigating Polar Exploration Rover, or VIPER, later this year. That mission will go to the poles and continue observations, similar observations as what NIRVIS will be making on Peregrine. Thank you.
I appreciate you, Tony. Next up, we have Richard Elphic. Richard?
Thanks, Nilafar. Hi, I'm Rick Elphic. I'm the principal investigator for the Neutron Spectrometer System, or NSS. NSS is a direct descendant of the Lunar Prospector Neutron Spectrometer, which successfully mapped possible ice at the lunar poles while in orbit 25 years ago. Developed in partnership with Lockheed Martin Advanced Technology Center, NSS measures neutrons coming up out of the surface, which can tell us a lot about the makeup of the landing site. We don't expect natural water at this Peregrine landing location, but the lander will spray paint the surface with its rocket exhaust during descent. That exhaust includes H2O, water, and NSS will look for changes in the deposited water over the course of a lunar day. With its companion instruments, NIRVIS and PITMIS, NSS may help us better understand how water molecules migrate and possibly end up at the cold lunar poles, as Tony described just earlier. Another NSS will be carried by the VIPER Lunar Polar Rover later this year. Thank you.
Thank you so much, Rich. Over to you, Barbara Cohen.
Hi, I'm Barbara Cohen from NASA's Goddard Space Flight Center, and I'm the principal investigator for the Peregrine Ion Trap Mass Spectrometer, or PITMIS. PITMIS is based on ESA's very successful mass spectrometer that flew on the Rosetta mission and measured gas molecules in deep space and on a comet, some of which are similar to what we might find in the lunar exosphere. We're really excited to fly PITMIS on Peregrine Mission 1 because it's very highly complementary to NSS and NIRVIS in trying to understand the processes of volatile delivery and movement around the lunar surface, as you just heard Tony and Rick describe. PITMIS has the ability to measure the low level of gases expected in the lunar exosphere to characterize how they're released and how they move around, especially species that are of interest to both science and exploration, like water. As the gas molecules bounce around the surface, they enter our instrument passively through a door at the top. We ionize those gases and trap them in an electronic field. Then we release them from that electric field according to their mass to charge ratio. And so we measure the makeup of the exosphere, the chemical compositions in the exosphere. We can scan that composition roughly twice a minute. So we're really sensitive to changes with time, and we'll be looking for those time changes, both due to the interaction of the lander itself as it lands and kicks up dust and regolith, and to rovers that the Peregrine Mission 1 is going to deploy onto the surface, as well as natural variations like temperature throughout the lunar day. The last mass spectrometer that landed on the surface of the moon was in 1972. We hope that PMIS will be the next, but it's only the first of several mass spectrometers that are going to be carried by upcoming CLPS missions all over the lunar surface, and that's going to help us build up a three-dimensional view of the natural lunar exosphere. Thank you.
Appreciate you, Barbara. And finally, last but certainly not least, we have Daniel Cremons. Daniel, over to you.
Hello, I'm Daniel Cremons from NASA's Goddard Space Flight Center, and I'm the Deputy Principal Investigator for the Laser Retroreflector Array Instrument, or LRA. LRA is a completely passive instrument consisting of a hemispherical array of special glass prisms called retroreflectors, which return light back towards the illumination source. This same phenomenon causes cat's eyes to shine in the darkness and road markers to light up under a car's headlights. On a CLPS lander, LRA acts as a precise marker of the lander position that will be visible under illumination from a laser ranging system on board an orbiting or landing spacecraft. LRA requires no power, thermal control, or interaction with the lander, allowing it to be used for decades on the lunar surface. LRA will be used to geolocate the lander on the surface with high precision, measure any changes in the lander position over long time periods, and determine the precise orbit or landing trajectory of a spacecraft illuminating it. In addition to the Astrobotic Peregrine Mission 1, LRA is manifested on other upcoming CLPS missions as well as lunar landers from other national space agencies. Thank you.
Perfect. Thank you so much, Daniel. And thanks again to all of our briefers for those initial remarks. For awareness, we also have some additional NASA subject matter experts on the line in case there are some specific topics or questions that come up. So as a reminder to our team that's on today, to ask your question, please raise your hand to add your name to our queue and ask your question. You will be unmuted at that point. Once your name is called, please state your name, affiliation, and to whom you'd like to direct your question. If you find that your question has already been answered, please lower your hand to withdraw it. With that, I'm going to take a look here. So first up, we have Joey Roulette. Joey?
Questions for Chris. Can you guys hear me?
Yes, loud and clear.
Okay, sorry, it said I was muted. Question for Chris Culbert. Since this is a commercial mission, does NASA know Peregrine's full payload manifest, or might there be payloads that the agency might not be aware of? And then, just second question, there are concerns that some people have about the lander's payloads, like a sports drink can, and there's human and dog ashes, I think, on the payload as well. Does NASA share concerns about that it could maybe set some kind of negative precedent for how the moon should be used? And if not, what is the agency's thinking on those types of payloads? Thanks.
Well, I'll start with the first part. Yeah, to a large extent, I think we know most everything that any of our commercial vendors are flying. They don't have to clear those payloads with us. These are truly commercial missions. It's up to them to sell what they can sell. But in the process of making sure that our payloads needs are being met, we obviously have a lot of discussions about how the payloads fit together. So I think we have reasonably good awareness about what payloads are on these commercial missions. And to your second question, it really isn't something we don't have. These are commercial missions. We don't have the framework for telling them what they can and can't fly. That'll be a discussion. Probably the approval process doesn't run through NASA for commercial missions. I believe it goes through the FAA. And if there are guidelines that the US government wants to apply, that would come through that process.
Thank you so much, Chris, for responding to that question. And thanks, Joey. Next up, we have Will Robinson. Will?
For taking the time to answer our questions. Question directed towards Daniel Cremon regarding the LRA. You mentioned that those are going to be manifested on multiple CLPS payload missions, as well as some of the landers from other countries' space agencies. Was that born out of conversations through the Artemis Accords, or how are those non-CLPS missions from NASA being done in coordination with this program? Thanks.
Yeah, thanks for the question. So the NASA payloads, the LRA payloads that have flown on international missions have all been worked through separate international agreements between NASA and the space agency in question. So those have been worked through memoranda of understanding separate outside of the Artemis Accords.
Thank you so much for your question. As a reminder, when you get into the queue to ask your question, you will be unmuted. So once your name is called, please state your name, affiliation, and to whom you'd like to direct your question. Our next question comes from Jeff Faust. Jeff?
Faust of Space News. Question probably for Tony, Richard, or Barbara. Besides water, what other volatiles do you expect to be capable of measuring, whether it's from the exhaust, from the lander itself, or natural sources with your instruments?
I can start answering that, and then Rick and Barbara can jump on in and add to correct. The NERVIS instrument wavelength range, the colors it measures, was actually selected to cover a really wide range of potential volatiles, things we expect in the exhaust besides water, including carbon dioxide, but can also measure more exotic things like ammonia, methane, etc. Some of the volatiles that have a little bit higher volatility temperatures, meaning more stable, are things like sulfur-bearing compounds, sulfur dioxide, hydrogen sulfide, and there are some indications of those at the poles. It'd be interesting to see if there is sulfur at this landing site. If you recall, the Chandrayaan-3 rover detected sulfur at about 70 degrees south. We will also be able to look at hydroxyl with the NERVIS instrument. Hydroxyl is like water, just short a hydrogen atom. It's OH, but it can be bound chemically into the regolith matrix, and so actually be stable at much higher temperatures. We'll be able to sort out what's water, H2O, and what's hydroxyl, OH, with the NERVIS instrument. I'll let Barbara and Rick then jump in.
Perfect. Thank you so much, Tony. We'll pass that over to Barbara. Barbara.
Yeah, sure. PIMS is also sensitive to a wide range of compounds. We have to wait for them to come to us. We're a passive instrument, so anything that's in a gaseous state will come to us and we can measure that. So hydrazine, for sure, we're very interested in understanding the decay of the hydrazine plume from the engines, the descent engines. Things like carbon dioxide, carbon monoxide, ammonia, if it's there, methane, if it's there, all of those things, especially noble gases, is something of our personal interest as well. So all of those that are detected from orbit in the lunar exosphere, we're hoping to get a complementary measurement on the surface as well.
Thanks for adding, Barbara. Richard, anything you'd like to add?
Sure. The neutron spectrometer is really most sensitive to anything that has hydrogen in it. So things like methane, ammonia, water are the possible candidates for being able to be measured. But the thing about the neutrons is that it's a bulk measurement of about a meter's worth of regolith below the lander. So it's not a superficial measurement at all. It's actually integrating everything below the very surface. So it's different in that respect from both PITMUS and NERVIS, but it's a very complementary measurement because it's really addressing the bulk of the material below. And I expect that we'll see some changes in the neutrons as we go along through the lunar day, but I think it's really going to be PITMUS and NERVIS that kind of lead the charge on seeing changes from day to day and hour to hour as the sun comes up and goes overhead and then begins to set in the west.
Thank you, Richard. And thanks for your question. Next up, we have Kristen Fisher over at CNN. Kristen?
Hello, can you hear me?
Loud and clear. Thanks, Kristen.
Okay, great. And apologies if this is a bit of a duplication. My phone cut out right as Joey was asking this question, so I couldn't hear the full answer. But It's a follow-up to what he was asking about some concerns from Navajo Nation about sending cremated human remains to the moon. So I think this question is for Joel. Just hoping to get some kind of response from Navajo Nation's comment where they said, we view the moon as part of our spiritual heritage. The act of depositing human remains and other materials which could be perceived as discards in any other location on the moon is tantamount to desecration of this sacred space. That's their quote. Just hoping to get a response from NASA on that. Thanks.
Perfect. Joel, over to you on that one.
Nilüfer, can you hear me?
Loud and clear, Joel.
Okay, thanks. Well, thanks for asking the question. I guess I'll start off first by saying, of course, we're all excited to be on the verge of this very first commercial Lunar Payload Services flight, which will be the first launch to the moon by an American company as opposed to the government. And this, of course, is part of the new approaches being used to get to the lunar exploration as part of the Artemis initiative. And that means we're going with more partners than ever before, which means it'll give us more opportunities. But with those new opportunities and new ways of doing business, we recognize that some non-NASA commercial payloads can be a cause for concern to some communities. And those communities may not understand that these missions are commercial and they're not US government missions like the ones that we're talking about today. Now, for our own missions and our own cargo and our own payloads, NASA works to be very mindful of potential concerns for any work that we'll do on the moon. In this particular case, I want to reemphasize something that was stated earlier, which is that NASA really doesn't have involvement or oversight to the other commercial payloads, the non-NASA payloads that are on this launch. Unlike NASA missions for the CLPS deliveries, NASA purchases a delivery service from the American companies to send NASA-specific science and technology payloads to the moon. The lunar lander, the lunar mission design, the launch vehicle that is picked by the commercial company are all the commercial company's responsibility. And so, for example, in PM1, the one that the landing mission that we're talking about the NASA science for today and the NASA technology, that's an Astrobotic technology mission, and it isn't managed by NASA. And we know that as you heard in the earlier question, we know that the American companies that we are flying these NASA CLPS payloads on also solicit other organizations' payloads to be transported to the moon to be paying customers. And we expect that. We know that that is part of developing a lunar economy, that we want non-government customers for these companies, these American companies. So NASA did receive a letter from Navajo Nation requesting a tribal consultation to discuss deliveries to the moon on non-NASA missions. You probably saw reports of that in the media. That letter was addressed to both agencies, NASA, which is who everyone traditionally associates with the moon and of course is sponsoring the CLPS deliveries, but also the Department of Transportation. And an intergovernmental team is currently looking into this with more detail. There's an intergovernmental meeting being set up with the Navajo Nation that NASA will support. So that's about all we can share at this time about the reaction to the letter. I will add that, American companies bringing equipment and cargo and payloads to the moon is a totally new industry, a nascent industry where everyone is learning as we have set this up the past few years, how it's going to operate. And we're learning new things, every month, every year. And guidelines, as you can imagine, in response to that will be examined and developed. We take concerns like expressed from the Navajo Nation very, very seriously. And we think we're going to be continuing this conversation. That's about pretty well all I can say to address the question today, Nilüfer.
Thank you so much, Joel. Really appreciate it. Next up, we have Marcia Smith from Space Policy Online. Marcia, you're up.
Can you hear me? Because I can't hear you.
Yes, loud and clear.
Okay. Mine is actually another follow-up on the question about the complaint by the Navajo Nation president. And I do understand it's not a NASA mission and you don't control the other payloads, but I am just wondering whether or not NASA feels that it has an obligation to inform the commercial companies if they've been made aware of sensitivities by certain groups like the Navajo. Is there somewhere in your list of things to discuss with the commercial partners, any sensitivities that have been expressed to you in the past?
Hey, Marcia, I'm going to address this right now. So at this point in time, because this is an ongoing discussion, we really appreciate the question and we understand that this is a topic of concern, but we've answered as much information as we can right now on this subject. So we're going to have to go over to the next science question, but we really appreciate it and we'll have more to come on this. Thanks. I muted myself. I apologize. Next up, we have Alexandra Witz from Nature. Alexandra, you are up.
I guess I'll pivot from following up on the Navajo Nation questions then to ask about science. Let me ask Paul. I want to know, can you talk a little bit about kind of the overarching scientific guidelines through which the program sort of decides what payloads to send where on which mission? So for instance, there's some payloads that have got bumped from this first Astrobotic flight. There are other payloads that are repeated on future flights to other landing sites. What are the kind of overarching guidelines and strategy the program is using to decide what payload to send where, which ones to send multiple places, and which sites to send them to?
Thanks. I've been mostly working the coordination for this particular mission. So I don't have a lot of say in how that strategy is formulated. However, I can talk in general about the CLPS strategy. I mean, obviously, the CLPS the philosophy is to send multiple landers to multiple locations, and there's various ways in which CLPS payloads are manifested through a manifesting board here that NASA runs. If Chris might be able to provide more details.
I was going to actually thank you, Paul. I was going to call on Chris as well as Joel, if you had anything to add to the question that was asked.
This, Chris, I'll just add that remember, these are the first missions. You'll see progressively more complex science as the commercial community demonstrates what they're capable of. These early missions had some clear science opportunities, but we weren't being driven by specific science strategies until we were reasonably confident that the marketplace could actually deliver and land on the moon softly. So while we'll get some really fascinating science and some good technology demonstrations out of these early missions, we weren't being driven by on a specific strategy yet. You'll see more of that in future missions.
Thank you so much, Chris. I would also like to call on Nikki Werkheiser to talk a little bit about the tech demo and strategy behind that.
Yes, hi there. So we work very closely with our Science Mission Directorate as well as our Exploration Systems team. We are on the manifest board that Chris had just referred to. In addition to that, we're one NASA, right? So we want to look at every possible opportunity to partner with industry, to partner with other NASA groups and organizations, as well as our international partners. So you heard me mention, for example, with Astrobotic, there have been around 40 or so SBIRs in a little over the last decade, as well as 3 tipping point awards. If you're not familiar with the tipping points, they've been wildly successful, and they do actually lead, as well as our SBIRs, often to flight opportunities, either our suborbital and now on CLPS. We just made some recent awards here in 2022, and many of those, I can't remember the percentage right now. I think it was definitely over 60%. We're focused on lunar surface technologies that folks hope to fly, and so many of those are either partnered with or are CLPS vendors, such as Astrobotic. So it's just a way that we all work together, and there's a lot of communication between the community on making sure that the technologies that we all need for exploration and science are being matured and going up that TRL chain so that we can include those in Artemis missions.
Perfect. Thank you so much for that ad, Nikki. I see that we have Joey Roulette up for asking another question. Joey, you are unmuted.
Hey, thanks. This isn't about the Navajo Nation concerns, but I just wanted to ask a question, I guess, for anyone who would be down to answer, any of the scientists on the panel. How does it feel like? What are your guys' reactions to those types of missions where it's non-NASA, but it's also not scientific? We talk a lot about the moon being used for these awesome scientific purposes, and how does it make you guys feel knowing that there's something like the ashes being scattered across the surface, or other marketing opportunities that are being put on the lunar surface? I'm just curious to hear your thoughts on that. Anyone who'd like to answer?
I'll ask Joel to lead with that question and then see if Chris has anything else to add. Joel?
Well, I'd say that to tie back to what I said before, we are really trying and doing in contracting for these delivery of the NASA science to the moon to have the commercial industry really get commercial users for the moon. And we know that, and a lot of those uses are not going to be science. They're going to be industrial uses. As you said, they could be advertising. They could be other potential uses. And if you go on to, say, Astrobotic Technologies website, you'll see a list of, for example, on this particular commercial mission, all these different types of things that are non-NASA experiments that will be flown to the moon. So we really want to develop not only the lander providers as a service provider pool that NASA and others can use to deliver cargo, all types of cargo to the moon at a frequent cadence and a lower cost in the future. But we recognize that a lot of those applications or uses are definitely not going to be science. And as I said earlier, we're going to learn through these first landings and the follow-up landings all the different issues or concerns that are generated by that. And I'm sure that as time goes by, there are going to be changes to how we view this, or how industry itself maybe sets up standards or guidelines about how they're going to proceed. That's about all I could add. No, for Chris.
Yeah, actually, I don't have much to add to that. I'll just echo what Joel was saying. This is a new endeavor, both from a technical perspective. There's no commercial companies ever landed anything on the moon before, and it's new from an economy perspective or a market perspective. I don't think it's all that clear, certainly not to us in NASA, and it's probably still emerging or developing in the commercial marketplace what warrants interest and would drive potential revenue and profits. So I think you'll see that evolve quite a bit over time, but I think the first step is its successful landing. That's what we care about most in these early steps.
Perfect. Thank you so much, Chris, for responding to that. And we'll share more information regarding the Navajo Nation as we know more about the interagency team governmental team that is discussing it. So as a reminder, today's briefing is on NASA's Commercial Lunar Payload Services, or CLPS initiative, where we aim to address the lunar science deliveries or the NASA-provided payloads flying aboard Astrobotic's Peregrine lunar lander. We have time for one final question, and that final question is going to go to you, Will Robinson-Smith. So your line is now open.
Appreciate closing out the teleconference here, and good luck to all involved. Follow up on the conversation about manifesting payloads, and I suppose this would go to Nikki, and perhaps Chris, if you'd like to add it as well. If on the hopefully low off chance that this mission is unsuccessful in making a soft landing, I understand that there are, plenty of other payloads that are manifested on future CLPS missions, but is there a thought that if Peregrine 1 does not make it safely to the surface of the moon, that any of the 5 NASA payloads here may specifically be reflown on future CLPS missions? Thanks.
Hey, Nilofer, I would take that one.
Perfect. Thank you, Joel. I was about to
Nikki and
call on you.
Chris. And that is that we, in some cases, for some of these scientific instruments, as was mentioned by some of the briefers, we have other copies of them already slated to fly on other CLPS missions. If this particular mission does not successfully soft land, NASA does not today plan to rebuild the instruments and then fly additional copies on future missions other than what we've already planned today.
Thank you so much, Joel, and thanks to all of you who submitted questions. And thanks to the briefers today for taking the time to discuss NASA's CLPS initiative and their payloads aboard Astrobotic's Peregrine Mission 1. As a reminder, Astrobotic is scheduled to launch aboard ULA's Vulcan rocket no earlier than January 8th, 2024. We really appreciate you joining us today to have this discussion, and a recording of this briefing will be available on nasa.gov/CLPS. That will wrap today's briefing. Have a great day, everyone.